Hello, grade 12 learners. Welcome to another exciting session of mathematical literacy. Today's topic is data handling with a specific focus on the measures of spread. Now, under measures of spread, we are going to be looking at the concept of range. We are going to look at the concept of the interquartile range, which is also known as the IQR. And lastly, we'll be looking at the box and whisker plots. At the end of this lesson, we will address calculating the range, calculating the quartiles of an arranged data set, and thereafter calculating the interquartile range by using the IQR formula. Lastly, we'll use the box and whisker plot to analyze and interpret the 5-number summary. These are the keywords, or rather the definitions, that we must make sure that we are familiar with as we are revising this section. These terminologies are important because they are also examinable. So in the exam, you can be asked to explain what a quartile is, or you can be asked what does the acronym IQR stand for. You should know that IQR stands for interquartile range, but you should also be able to explain them. What you should be knowing from grade 10 and grade 11, the beauty of this section is that it's actually a topic, data handling, that you've already studied in grade 10. So in grade 10 and grade 11, you calculated the mean, the median, and the mode. So this knowledge will come in very handy as we are doing the measures of spread in grade 12. And in grade 12, what you should be knowing is arranging your data in ascending order. You will see when you calculate the quartiles, we calculate the quartiles with the data that is arranged in ascending order. You should also have learned to calculate the median of a data set. You will see how important the concept of median is when it comes to the calculation of the quartiles. And the common mistakes that are committed by candidates in this section: learners cannot work with negative numbers when it comes to the concept of range, resulting in failure to identify the maximum and the minimum values. Learners struggle to identify the box and whisker plot diagram. Learners could not calculate the interquartile range. Instead of calculating the interquartile range, they calculated the range. So today's lesson, we are going to be addressing these common errors to make sure that you don't commit the same mistakes as you sit for your National Senior Certificate exams. And for you to improve your performance in this section, you must master the following competencies. Your communication skills, they must be sharp. You should be able to express yourself. And your research skills, your active learning methods, critical thinking skills, and lastly, the fundamental numerical concepts and principles. Let us take a quick short ad break. We'll be back very soon. Welcome back. Let's look at our first concept, which is the concept of range. With the range, these are the common errors. Learners could not work with negative numbers when it comes to the concept of range, resulting in failure to identify the maximum and the minimum values. So the key theory aspects that you should be knowing is that the range is the difference between the largest or the highest, or sometimes the other books can say the maximum and the minimum value. And then we should know that in MathLit, when you talk about a difference, you are actually referring to minus. You mean the difference means minus. That is what you must know, that in Meslick, when you talk about the difference, we are talking about minus, or rather subtraction. So the range is a measure of spread because it tells you how spread out the data values are. A small range suggests that the values are grouped closer to the median, while a bigger range suggests that the values are more spread out. So this is the formula that we can use to calculate the range, to say range is the highest value minus the lowest value. So you are expected to know this formula by heart, because in the exam, this formula will not be given to you. Sometimes they can even ask you to give the formula for the range. So instead of using the highest value, you can still say that range is the maximum value minus the minimum value. It means the same thing. Let's look at this example. Find the range of the number of death fatalities that occurred over 6 months on the N4 highway. So these fatalities, they occurred over a period of 6 months, meaning in the first month it was 3 accidents. In the second month it was 7. The third month 8. The fourth month 5 accidents. The fifth month 4 accidents. And the sixth month, the last one, there were 10 accidents. So remember, when you want the range, we say the range is the difference. You subtract the highest value from the smallest value. So let's see how you will tackle this one. So the lowest value from this data, it is 3. And the highest value, I think we can all agree it is 10. So the range would be the maximum value minus the minimum value. And as you can see, it is 10 minus 3, which is equals to 7. This is how you determine your range. Another example, the maximum and minimum temperatures of a town for a week are recorded. So you've got 32 degrees Celsius, 18 degrees Celsius, minus 5, 0, 35, minus 7, and 3 degrees Celsius. So calculate the range of the above data. Before we can calculate the range, I would like for us to first arrange this data in ascending order. Remember, ascending means from the smallest to the biggest. So looking at this, what is the smallest value? The smallest value is minus 7. The next one is minus 5. The next one is 0. 0 is bigger than minus 7. Believe it or not, yes. And then after 0, what do we have? We've got 3. After 3, we've got 18. And then there's 32. And then there's 35. Meaning that our maximum is 35. Our minimum is minus 7. So let us see how we would calculate the range for this data. You will say, remember the formula, it is maximum minus minimum. So our maximum is what it is? It is 35. You'll say 35 minus, because the formula says subtract, minus. And then the minimum is what? Is minus 7. That is where you see here it is 35 minus 7. If you punch this in your calculator, minus and minus will change and become a positive. Therefore, 35 plus 7 will give us 32 degrees Celsius. This is how you calculate the range if you have a mixture of positive and negative numbers. After the range, the next aspect we're going to look at, it is the interquartile range. With the interquartile range, the common errors that were committed by learners is that learners could not calculate the interquartile range. Instead of calculating the interquartile range, they calculated the range. So you will see from these coming examples that the range and the interquartile range are not the same. Range is the difference between the maximum and the minimum value, whereas your interquartile range is the difference between your quartile 3 and your quartile 1. So the key theory aspects when it comes to the interquartile range, this is a new section that you are doing in grade 12. The interquartile range is the difference between your upper quartile and your lower quartile. The upper quartile is known as the Q3, your lower quartile is known as the Q1. So the formula that can be used then to calculate the interquartile range, it is IQR equals to Q3 minus Q1. Again, you are expected to know this formula by heart. The lower quartile, which is the Q1, it is the 25% mark of your data set. Whereas the quartile 2 is also known as the median. That is your 50% mark of your data set. The upper quartile, which is also known as Q3, that is your 75% mark of your data set, or it is your upper 25%. Upper 25% mark of your data set. Before you can calculate the interquartile range, you first need to determine the quartiles of the data. And then how do we do that? Let us look at this example. The following data has been released by Statistics South Africa on fatal crashes for November and December 2021. So we've got the months November and December, and all the 9 provinces data set are collected there. In November, Gauteng had more fatalities as compared to December, and then we can check all the other provinces. 3.1, arrange the data for December in ascending order, meaning you must focus on this row here, the row of December, and it must be arranged in what? In ascending order. Remember, ascending means what? From the lowest to the highest. So when you arrange, the smallest is 32 there, and the highest is 227. There we go. The second question, calculate quartile 2 for the December data. Quartile 2 is also known as the median. Now, the first step, the data was already arranged in the previous question. It is 3278. The data is arranged, and then from these values, we can all see that this is the median, and the median is Q2. Therefore, the value of Q2 is 109. Q2 and median are the same thing. Example 3.3, calculate the interquartile range. So there is our data still arranged. Before you can find your interquartile range, you start with Q2, which is your median, and we've got our Q2. Now that we've got our Q2, to calculate our Q1, we'll focus on the first half of the data. We're looking for the median of this data. So the median is right here on this arrow, meaning that it is these two values. So to get our Q1, we'll add these two values, 78 plus 19, and we'll divide it by 2 to give us what? To give us 84. And then we do the same with quartile 3. We focus on the second half of the data, and then we've got two values in the middle. We've got 135 and 182. That is why we will take 135 plus 182 and divide by 2 to get 158,5. And this is our quartile 3. Once we've got your quartile 1, you've got your quartile 3. Now you can calculate the interquartile range by using the formula Q3 minus Q1. And then our Q3, it is 158,5 minus our Q1, it is 84. So you subtract 84 from 158.5, you get you get 74,5. So this is how you calculate the interquartile range. Let us take a quick short ad break. We'll be back very soon. Welcome back. Let's look at another example. Example 4. The data set below shows the math literacy assessment results of the two friends, Lerato and Palesa. So Lerato's results are 60%, 63%, 68%, 72%, 77%, and 80%. Whereas Palesa's results are also provided there. 4.1, we must combine their results and arrange them in ascending order. Remember ascending order from the lowest to the highest. So this is how we will arrange the data there. It means the lowest mark for both of them is 60% and the highest mark is 80%. So when you arrange, you make sure that you count that you've included all the values. 4.2, calculate the interquartile range of the above data set. Remember, when you calculate your interquartile range, number one, you check that your data is arranged. Secondly, you find your median first. That is your starting point. So looking at this data, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Meaning that the median is the sixth value. 1, 2, 3, 4, 5, 6. This is the middle value. 1, 2, 3, 4, 5, 6. That is why Q2, it is 68%. So to find Q1, you'll focus on this data set here. What is the middle value? This is the middle value. This makes this our Q1. That is why you see then the 64. To find our Q3, we'll look at this data set here. What is the middle value? This is the middle value. Therefore, this is your Q3. That is why you see here Q3 is 72. And then the interquartile range formula, again, it is Q3 minus Q1. Remember, in the exam, you are expected to know this formula by heart. And then we substitute Q3 minus Q1 to give us the interquartile range of 8%. This is how you calculate the interquartile range. And then our last item to look at, it is the box and whisker plot. So the common errors in this section of box and whisker is that learners struggle to identify the box and whisker plot diagram. So what happened here in the exam, learners were given a diagram and they were asked to identify the type of diagram. So learners did not know that it is called a box and whisker plot. Learners could also not identify the 5-number summary that is presented on a box and whisker plot. In this lesson, I'm going to show you when we talk about a 5-number summary, what is it exactly we are referring to. So what you need to know is that the box and whisker plot is a visual representation of the 5-number summary of a data set. The 5-number summary is made up of the following: the minimum value, quartile 1, quartile 2, quartile 3, and the maximum value. So that is your 5-number summary. Here is an example of a box and whisker. So remember I said that is a representation of your 5-number summary. So the value that is here will always represent the minimum value. And the value that is here will always represent your maximum value. The value here, it is your upper quartile. This one here will represent your median. Remember, another word for median is what? Is Q2. And then this one in blue will always represent your lower quartile, or rather quartile 1. And if you want your interquartile range is between Q3 and Q1. So when you subtract Q1 from Q3, you will get what? You'll get your interquartile range. So what you see there on your screen, that is what we call a box and whisker plot. Very important, you will never be asked to draw a box and whisker plot in the exam. The box and whisker plot will be provided. Yours will be to interpret it. Let's look at an example here. Study the box and whisker plot below and identify the 5-number summary. So looking at our box and whisker plot here, this value here represents the minimum value. Whereas this one here represents what? It represents Q1. This one represents what? Q2. This represents what? Q3. And lastly, this one represents what? The maximum value. So this is our 5-number summary. So let us see how do we write it then. So when you answer this, you will say the minimum value is 70, and there it is 70. And then quartile 1 is 100. Where is quartile 1? There is quartile 1. It is 100. Quartile 2 is 110. There is quartile 2, and it truly is 110. Quartile 3 is 115. There is quartile 3. It is indeed 115. And lastly, the maximum value is 120. So the maximum value is right here. It is 120. 6.1. What is the median betting average? I'm sorry, let's read the context first. Example 6. The box and whisker plot below represents the betting averages of 160 cricketers who have betted in T20 matches since 1st January 2021. Answer the questions that are based on the plot. So there is our box and whisker plot. We know that this is the minimum. This represents Q1. This represents Q2. This represents Q3. And this represents the maximum. So this is what I'm expecting you to do in the exam. You label your box and whisker before you can even answer the questions. 6.1, what is the median betting average? The median, remember what is your median? You are looking at your Q, your Q2. So what is the Q2 of this data? It is 15.2. 6.2, how many players have a betting average of less than 6.25? So you go to your box and whisker, there is 6.25. So it means at this part, this is what this is, 25% of your data. That is why we are saying 25% multiplied by a total of 160 players. So it means how many players have a less than 6.25? It is 40 players. 6.3, what must a batsman's average be for him to be in the top quartile? Remember what is the top quartile? The top quartile is quartile, what is quartile? Quartile 3. So for them to be here, what must their average be? So here, the top quartile, it is Q3. So for them to be in the top here, it means they must perform above 25.5. So the answer is average must be above 25.5. Anything above 25.5 would put them in the top quartile. Let us look at the following practice questions. 1. The following box and whisker plot represents the summary of data collected about the amount of rand saved by learners in a certain school in the ordinary public school sector. 140 people took part in this survey. So this is very important. You know your sample. You are working with a sample of 140 people. So there is our box and whisker. When you are in the exam, before you even look at the questions, you already label your box and whisker that, okay, this is my minimum value. This is my quartile 1. This is my quartile 2. This is my quartile 3. And therefore, this is my maximum value. You haven't even answered the questions. Let us go to the questions now. 1.1, why is it important for a learner to save money? This is not only applicable to a learner, but also to grown-ups. The importance of saving up money, you save up to buy something bigger because you avoid getting something on credit. So you'd rather save up your money. And once you've accumulated that sum that you need, then you can use that money to buy something bigger. So for learners, for someone like you in your classroom, you could be saving up maybe to buy a bicycle, maybe to buy a handbag, or to buy a cell phone, or maybe you want earphones, or maybe you want to buy yourself a calculator, but you cannot afford to buy it cash. So you could be saving up for that item. So saving, we say that learners can save. The importance of saving would be saving to buy a bigger item. A bigger item like a calculator. You want to buy it, but you cannot afford to buy it cash. So you can save up your money. Once you've accumulated that amount, then you just go and buy your calculator cash. 1.2, what percentage of the people saves more than 65 rands? Where is 65 rands? This is 65 rands. And remember, this is your quartile 3. And the quartile are divided into this part. This first part, it is 25% from here to there. And in this other part, it's another 25%. That is why up to here is 50%. And then this part from here to there, it is 25%. That is why we are saying this is the lower 75%. And then from here up to here, it is another 25%. So what percentage of the people saves more than 65 rand? So more than 65 rand, it is this section here. This section here is more than 65. So what percentage is it? It is 25%. So the answer there would be 25%. 1.3, calculate the value of the interquartile range. How do we calculate the interquartile range? We know that the formula for the interquartile range, it is actually Q3 minus Q1. So from our box and whisker plot, we know that this is our Q1, this is our Q2, and this is our Q3. And then let us now substitute into the formula. Q3, we say it is how much? It is 65 minus our Q1, it's how much? It is 25. Let us take out our calculators and say now Q3 minus Q1, the answer is what is 20. I am getting 20 as the value of the interquartile range. 1.4, Busi claims that 70 people save between 15 rand and 35 rands. Verify, showing all calculations whether his statement is valid or not. So remember, there's a total of about how many people? 140 people. So between 15 rand, it is between this value and how much? And 35 rand. So it means up to here. And what percentage is this? Remember, this first part is 25%. This first part is 25%. So up to here, this is what this is, 50%. So if you want to know the number of people, you will take the 50% here. You will say 50%, which is the same as 50 over 100. And then you multiply by the number of people, which is 114 people. So if you punch on your calculators then, you say 50 divided by 100 multiplied by 140 people. 50 divided by 100 is 0.5 multiplied by 140 people. It gives how much? It gives 70 people. What was her claim? She claimed that 70 people save between 15 rand and 35 rand. And then yes, her claim is valid. So we'll therefore say, therefore, her claim is valid. Or you can say her statement is valid. Doesn't matter. Either way, the most important thing is that it is a valid statement. Let's look at the second one. The box and whisker diagrams representing the percentage achieved in the exam of the two mathematical literacy grade 12 classes consisting of 26 learners each are shown. The arranged percentage marks of the classes are also given. So let us first look at the box and whiskers. We've got the performance for class A. This is the box and whisker for class A. And then we have the performance for class B. And this is the box and whisker for class B. So what we are seeing here are the arranged. And looking at 19.8, 89.9, it means that they are actually arranged in ascending order. These are the arranged percentage marks for class A. It means for class A, we can see that the minimum value, it is 19.8. So the minimum value is right here, right below the 20. And then the maximum value is 89.9, meaning that your maximum value is right before 90, which is 89.9. 2.1, calculate the missing value x by reading the median value from the box and whisker plot. So our value x, remember this is the data for class A, and the median for class A, this is the median for class A. And then if you use your ruler, it's right here. It means the median, or rather the value of x, it is actually equals to what? It is equals to 60%. So that is the value. When you see x, you now know that you must replace it by what? By 60%. 2.2, calculate the probability of randomly selecting a learner from class A with a mark less than 79.9%. Remember, when you see x, what you write 16. So any value that is less than 79.9, here is our 79.9. It means you don't include 79.9. So you'll start counting here. H is also a value, so we'll include it. So it is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So it is 18 over a total of how many values? It's 18, 19, 20, 21, 22, 23, 24, 25. So it is 18 over 20, 25. That is the probability. So there was no instruction that the probability must be in a percentage or a decimal. So we'll leave it as 18 over 25. So the first mark would be for the 18, the second mark would be for the 25. 2.3, compare the interquartile ranges of class A and class B. Remember, the interquartile range, let's say interquartile range, and then we'll say A, meaning for class A, it is Q3 minus Q1. So what is the value of Q3? This is Q3. Q3 is almost what? Almost 80. And this is Q1 for class A. Q1 is almost what? It's almost 30. So we'll then say 80 minus 30, which is equals to, take out your calculators and punch 80 minus 30. It is equals to 15%. And then if we want the interquartile range for class B, this is equals to the formula Q3 minus Q1. So let us check class B. What is Q1? Q1, it is 20. What is Q3? Q3 is 70. So Q3 is 70 minus your Q1 is what? Is 20. So 70 minus 20, when you punch it in, you must get 15%. So they said we must compare. When you are comparing them, what can you see? What can you say about them? What are you noting? The interquartile ranges are the same. Their interquartile range, their I, Q, R are the same, or they are equal. So that is what you can say if you have to compare them. Remember, for you to compare, you must first perform calculations. Number 3, the two box and whisker plots represent the percentage marks achieved by two grade 12 classes. Each class consists of 26 learners. The percentage marks for class A arranged in order are given below. So this is very important. The total number of learners in each class, there is 26. So this one is almost similar to the previous example, whereby we've got the two classes. There's class A and there is also class B. And then the marks of class A again arranged are provided here. So we've got F, meaning that F is the lowest value because they are arranged. And then we've got 90, meaning 90 is your highest value. The moment you see F, you see H, you must know that it means the examiner will want you to find the values of those missing items. Note that F is the lowest percentage mark. So we have already been told that F is the lowest, meaning that F is less than 58. And then H is a percentage mark between 75 and 80. So the value of H, when you calculate it, you must know that it is between 75 and 80. We have been doing a lot of talking. I just want us to take a quick short ad break. We'll come back and see the questions from this concept that we are doing now. Let's take a short break. We'll be back soon. Welcome back. Let's look at the questions. 3.1. Which one of the following terms best describes the data above? Is it categorical? Is it numerical? Is it qualitative data? This data, because it contains numbers, it's about the percentages. This data is definitely a numerical data. And remember, in mathematical literacy, we always talk about either categorical or numerical data. If it is categorical, that is when it will be classified into groups. Like it can be classified into groups of gender, it can be classified into color, it can be classified into flavors. But because this one is numbers, therefore it is numerical data. 3.2, determine the percentage of data values that lies between the upper quartile and the lower quartile. The value that lies between the upper quartile, this is upper quartile Q3 and the lower quartile Q1. What is that value? That is Q2. So what is the percentage of the data values that lies between the, it is Q2, which is what, which is 50%. The range of class A is 34. So they are already telling us, remember this is the data for class A. The range of class A is 34. Calculate the value of F. Remember what is F? F, they told us that F is the minimum value. It is the lowest value. So the fact that they tell you that the range, it means they want you to use the concept of range to help you calculate the answer to this question. So what do you know about the range? You know that range equals to maximum minus the minimum. So what is the range here? They told you that the range is 34. Where you see range, you will write what? You will write 34 equals to. Where you see the maximum value, what is the maximum value of this data? It is 19 minus, do we have the minimum value? No, we know that the minimum value is represented by F. So it means we'll have to find the value of F. So when we find the value of F, we are going to take the F to the other side because we want to have F is to something. So we'll bring F that side. Therefore, we'll have, okay, let me bring this side. It will be F equals to, we have 90 there. F equals to 90. So when you take 34, you bring 34 this side so that you can be left with F only. The 34 is positive. When you bring it this side, it becomes what? It becomes negative 34. So you've got 90 minus 34. Press on your calculators there. 90 minus 30 is 60. 60 minus 4, the answer is 56. Meaning that the value of F is equals to 56. And this makes sense because F is less than 58. So 56 truly is less than F. So this is how you use the concept of range to solve for the unknown. Okay, let's look at the next question, 3.4. Determine the median percentage mark for class B. Remember what is the median? Median, it is Q2. So this time our focus is on class B, and this is a median value. Look at it, it is here. So what is the value? It is 40. So you'll then say the median, it's equals to to 40. 3.5, determine the interquartile range for class B. What is the formula again for interquartile range? We know that interquartile range is equals to Q3 minus Q1. So where is our Q3 for class B? This is our Q3. It is at 70. Our Q1 is here. It is at 20. So Q3 would be 70 minus what? Minus 20. So 70 minus 20, the answer there is what? Is 50. So 50 is our interquartile range for class B. 3.6, give the modal percentage mark for class A. What is the meaning of modal? Modal, it is the value that appears the most. Remember this one, we already got it that it is 56, and this data is arranged in order, meaning that age, it is between the values of 75 and 80. But we know that age is not 75. They told us that it is between 75 and 80. So if we want the value of the mode, we want to look at the value that appears the most here. So we've got how many? 66. I'm suspecting 66. It is 1, 2, 3, 4. Whereas how many 73s do we have? 2. How many 75s do we have here? 3. So currently, from what we are witnessing, the mode is what? Is 66, because 66 appears 4 times. So the value of our mode here, modal percentage, it is 66%. That is the value that appears the most. Number 4, whooping cough affects the chest and nose and is characterized by a cough that makes a whoop sound. Number of cases reported per age group is shown below. So we've got the age group. For people that are less than 6 months old, the number of cases that were reported were 1,218. People between 6 is actually babies here. 6 and 11 months old, there were 612 cases reported. And between 1 to 6 years old, it was 3,051 cases reported. Between 7 and 10 years old, it was 2,221. Between 11 and 19 years old, it was N, meaning that it is unknown. Already, you must expect to be asked to find the value of N. So we've got also have a total. A total is also unknown. 4.1, N represents the highest number of whooping cases. It means N is your maximum value. Let me write it here that, okay, N is our maximum value. The range for the number of whooping cough cases for the known age group is 4,527. Determine the value of N. The fact that they speak about the range, it means they want you to use the concept of range to answer this question. And what do you know about the range? You know that range is equals to maximum minus then the minimum. So they gave you the value of the range. They say the range for this is what? It is 4,527. So when you see range, you will write 4,527 equals to. They say N represents the highest number, meaning it represents the maximum. So where I see the maximum, I will write what? I will write the value of N minus. So if N is the maximum, what is the minimum value? Let me erase this, not looking nice. If N is the maximum, what is the minimum? Then the minimum, the lowest value is 76. So we'll say N minus 76. I want the value of N. I want only N. So we'll take the 4,527. This 76 is negative. When you bring it this side of the equation, it will become what? It will become a positive. A positive what? 76 equals to N. And then here, these are the big values. You are going to need your calculator. Let us press on our calculators there. We want 4,000. Okay, 4,527 plus 76. And then I am getting 4,603. 4,603. This is the value of n. If you want to write it correctly, you can just say n equals to 4,603. But it doesn't matter. Whether you leave it here or you write it like this, the answer will still remain the same. 4.2, determine the interquartile range for the number of cases per age group. Remember, what is the interquartile range? It is Q3 minus Q1. But before we can do that, we first have to arrange our data. So when we arrange our data, we have the smallest. Remember, in the previous example, we calculated n. We said n was 4,603. Let me write it here. 4,603. So when we arrange, the smallest value there, it is 76. The next one, it is 612. The next value, it is 1,280. The next value, it is 2,221. The next value, the smallest value, it is 3,051. Another one, it is 3,429. And then the last value, the value of n, it is 4,603. So you've got 1, 2, 3, 4, 5, 6, 7 values, meaning that your median, it is this value. This is your quartile, what? Quartile 2. So since this is your quartile 2, this one would be your quartile 1. This is your quartile 1. And this here, this would be your quartile 3. This is quartile 3. Because remember, you are also including this value. So to find the interquartile range, we'll therefore say interquartile range equals to what? Equals to Q3 minus Q1. And then what is the value of Q3? It is 3,429 minus 612. We've got big numbers again here. They will require the use of a calculator. Let us take out our calculators. Let's do it together. So when we punch in our calculators, then we will say 3,000. Let me restart the calculator. 3,429 minus 612. I am getting 2,817. 2,617. This is the answer that I'm getting. That is our interquartile range. I hope you are following and you are enjoying this lesson. Let us take a quick short ad break. I'll be back soon. Welcome back. Let us wrap up today's lesson. So we looked at the concept of measures of central tendency with a specific focus on the range, the interquartile range, and the box and whisker plots. And we also spoke about the range a lot of times. We spoke about the maximum, the minimum values. We spoke about the interquartile range. We spoke about the quartile. So make sure that as you are preparing for the exams, you are very familiar with these concepts. These are the common errors that we addressed in our lesson, that learners could not work with the negative numbers when it comes to the concept of range, resulting in failure to identify the maximum and the minimum values. I addressed this in the lesson that if you are given a data set that has positive and negative, First, arrange your data. Then you can see which one is your minimum, which one is your maximum. And learners struggle to identify the box and whisker plot diagram. From here on, if you are ever given a box and whisker plot in the exam and you are asked to identify it, I hope you guys will ace that question. Learners could not calculate the interquartile range. Instead of calculating the interquartile range, they calculated the range. After today's lesson, I'm sure all of us know now the difference between the range and the interquartile range. Range is the difference between the maximum and the minimum value. Interquartile range, it is the difference between quartile 3 and quartile 1. Do not confuse the two. Both of them, they've got different formulas. You are expected to know those formulas by heart. And for further exam practice, you can please look at the 2021 National Senior Certificate November Paper 1, question 5.2, 2022 National Senior Certificate May-June Paper 1, question 1.3, 2022 National Senior Certificate November Paper 1, question 4.2.5, 2023 National Senior Certificate May-June Paper 1, question 3.2, and 2023 National Senior Certificate November Paper 1, question 3.3 and question 5.1.4. If you can do all these exercises from those questions, I can guarantee you whichever way these questions are posed in the exams, you will be able to answer them with confidence. And we have come to the end of our lesson. Thank you so much for tuning in. See you again next time.